Hello, everybody. I hope you've had a wonderful 24 hours. And if it's not been wonderful, as always, I hope that it only starts to improve. So today we're going to be looking at classifying polynomials and multiplicity. There are two ways that we classify polynomials. We classify them by either the number of terms or by the degree. So before we get started, let's go ahead and look at some of our vocabulary here. All right, so what is a polynomial? All right, a polynomial is simply the sum of one or more terms. The sum of one or more terms. Okay. That's a very brief definition of polynomial, but I think that's easy to remember. All right. Now, speaking of terms, terms are separated by either addition or subtraction. And from time to time, we might run across a problem that says, is the following a polynomial? Well, the key thing in recognizing a polynomial is that you don't want any negative exponents, because when you have a negative exponent, it drops a variable to the denominator. So basically, the variable, you cannot have any variable cannot be in the denominator. So it cannot or can't be in the denominator. Now, these next couple of vocabulary words you probably have recognized because we've dealt with them in the past. The first one is monomial. All right, so if you think about the prefix mono, we know the prefix mono means one. So monomial is simply a polynomial with one term. And I'm going to abbreviate polynomial as poly. A poly with one term. And when we have that term, it could be a number, it could be a variable, or it could be the product of a number and variable. All right, so for example, if we just had a number like -2, that's a monomial. We had just a variable like x squared, that's a monomial. If we had something like 4x, this is the product of a number and a variable, so that's still one term. Or we get something like, I don't know, 2xy squared. That's still one term because it's not separated by addition or subtraction. Our next term is a binomial. All right, looking at the prefix bi, we know bi means two. So a binomial is a polynomial with two terms. All right, so it could be something like 5 plus 7x cubed, or it could be something like x minus 4, or even something like 2xy minus 4x. These are all one term here, one term here. They're separated by addition here. One term here, one term here. They're separated by subtraction. One term here, one term here. They're separated by subtraction. So each one of these polynomials had two terms. So they're called a binomial. All right, then we have trinomial. All right, the prefix tri, like tricycle, we know that means three. So a trinomial is a polynomial with three terms. So here if we had something like 5x to the fourth minus 6x plus 7. All right, notice we have a subtraction here and an addition here. That is separating our terms. So we got 1, 2, 3 terms. All right, and then finally, if you have a polynomial that has 4 or more terms, all right, we're going to say that it is a polynomial of how many terms. But I will say sometimes from time to time, I will see when you have 4 terms, I've seen it called a quadnomial. So we could either say a polynomial of 4 terms, or we could say it's a quadnomial. If it had 7 terms, we would say a polynomial of 7 terms. All right, so here in the chart, they're asking us to classify by the number of terms. Okay, so I'm just going to come in here. I'm going to highlight my addition and subtraction real quick. That's going to help us determine our number of terms. All right, so in this first one, I've got 1 term, 2 terms, 3 terms. So they're separated by addition and subtraction here. So 1, 2, 3. Since it has 3 terms, it is going to be a trinomial. All right, 15. All right, I see no additional subtraction, so this is called a monomial because it's just 1 term, so monomial. And it's actually a specific type of monomial. It is when your term has no variables, it is called a constant. A constant is a term with no variables. And as I said before, you probably have already seen the word constant, and you know it's a term with no variables, but I'm really going to show you something really cool. All right, if we have 15, this is really 15x, but it's x to the 0. And we all know that anything raised to 0 is always 1, so what we have here is 15 times 1. So 15 times 1 is still 15. Because x to the 0 doesn't have any value that changes what you start with, that's why they never write the x to the 0. So they just call it a constant. Now I just blew your mind, because you are all math geeks like me. All right, for our next one, we've got 2 terms because they're separated by addition. So since it's 2 terms, it's going to be a binomial. Here we got 1 term, 2 terms, 3 terms, 4 terms. So we could either say a polynomial of 4 terms, and like I said, from time to time, I have seen worksheets call it a quadnomial, but I haven't seen anything above a quadnomial. All right, 2x plus 1. All right, so here we got an addition, so we got 1 term, 2 terms. So if it's 2 terms, it is a binomial. And then finally, we got 7x. That's just one term. So that's called a monomial. All right. So when they ask you to classify by the number of terms, these are the words that they want you to use. Monomial, binomial, trinomial, or a polynomial of blank terms. All right. So then next we're going to look at classifying by degree. All right, so we've got a couple of vocabulary words here. All right, let's talk about what degree is. All right, so a degree is simply, to put it in our terms, it's going to be the highest exponent of a polynomial or the highest sum of exponents of a polynomial. And the degree is going to be something very important, because as we move through this unit, we're going to learn something, well, the next either this unit or the next unit. We're going to move through something called the FTA, the Fundamental Theorem of Algebra. And the Fundamental Theorem of Algebra tells us how many solutions we should have according to the degree. So we know what a polynomial is. Standard form, we've talked about standard form. Standard form is from the greatest to the least. So let's just rewrite that just as a reminder. Standard form is the greatest exponent to the least exponent. That's the highest value to the lowest value. So it should be in descending order. All right, so right here for number 1. They're asking us to classify by the degree. All right, so classifying by degree, we need to know what each degree represents. All right, so I'm going to come right here, and we're going to write out our degrees. All right. All right, if your degree is equal to a 0, then it's going to be a constant. If your degree is a 1, then it's going to be a linear function. If your degree is equal to a 2, then it's going to be a quadratic function. If your degree is equal to a 3, then it's a cubic function. If your degree is equal to a 4, then it's a quartic function. And if your degree is equal to a 5, it's a quintic function. And anything greater than 5, so any degree greater than 5, it's called, let's change it to greater than or equal to 6. So let's just use 6, because 6 is greater than 5. So it would be called a 6th-degree function. If it was a degree of 7, it would be called a 7th-degree function, and so forth and so on. Okay, so again, if they ask you to classify by the number of terms, use the monomial, binomial, trinomial. If it asks you to classify by the degree, we're going to use constant, linear, quadratic, cubic, quartic, quintic, or blank degree polynomial. All right, so going back to number 1. We want to know, is this in standard form? Well, it's the only term, so it's already in standard form, so we don't have to rewrite this. I'm just going to put SF because it's already in standard form. But we want to know the degree. So to find the degree, all you do is just look at the exponent. This only has one variable, so that one variable has a degree of 3. So here we have a degree of 3, which makes that a cubic function. All right, so this would actually, if I wrote the full thing out, this would be a cubic monomial if they asked me to classify by degree and number of terms. All right, here we have a monomial, but notice we have two variables. Right here it said sum of exponents. When you have more than one variable in the same term, you add those exponents. Okay, so right here I'm going to say 3 plus 2, which gives us 5. So the degree here would be 5, and with a degree of 5, that makes it a quintic. So this is a quintic. And if they asked us to classify by degree and size, it would be a quintic monomial because it's only one term. And since this is only one term, it's already in standard form. All right, number 3. Again, it's one term. It's a monomial, so there's no ordering to it. It's going to be in standard form. And remember a while ago I said when it's a constant, it has an x to the 0. So what is your degree going to be? Here your degree is 0, and that would make it a constant function. It would be known as a constant monomial. All right, so then for the next several problems, you notice we go from monomials to, let's say we got 3 terms, 4 terms, 5 terms, etc. So let's see how we're going to work these out. All right, so for this one right here, when you have more than one term, what you're going to do is you're going to look at each individual degree and then choose the largest one. So right here we would say 2 plus 2, we get 4. Right here, the degree of that term would be a 2, and the degree of that constant there would be a 0. Is this in standard form? Does it go from the biggest degree to the smallest? Yes. So this right here is already in standard form. And we know the degree of each individual term. So once you find the degree of each individual term, you choose the biggest degree. So here, the degree would be 4. The degree is 4. And if its degree is 4, we know it's going to be a quartic. And if they were asked you to classify by degree and number of terms, this would be a quartic trinomial because it has 3 terms. All right, for number 5. All right, let's find our degrees of each individual term. All right, z to the first, so that will have a degree of 1. All right, ab. A has an exponent of 1, b has an exponent of 1, so 1 plus 1 is 2. Whenever your term has more than one variable, you add those exponents. All right, here we have a squared and b to the first, so 2 plus 1 is 3. And then 16 is our constant, so it has a degree of 0. All right, so what's the biggest degree? Well, the biggest degree is 3. So the degree here would be 3, so that makes that a cubic function. So it would be a cubic quadnomial. And let's look to see if it's in standard form. Notice it goes 1, 2, 3, 0. Does it go from the biggest degree to the smallest? No. So we've got to put it in standard form. So starting with our biggest degree of 3 came from negative 2a squared b. So we would write negative 2a squared b. Our next biggest degree is the positive 7ab, so plus 7ab. Our next one has a degree of 1, so minus 3z. And then our constant, plus 16. So this is now in standard form from the largest degree to the smallest degree. For number 6, We're going to come right here. Let's see, we got an x to the first and a y to the first, so that's a 2. Then the degree here would be 3. 2 plus 1 would be 3, and the y is a 1, so that would be 1. Now, if you notice here, we've got the largest degree is 3, so it's definitely a degree of 3, which makes it a cubic, but it's not in standard form. So when you have multiple terms that have the same degree, you always go by alphabetical order. So our variables here are x and y's. So x comes first in the alphabet, so what we're going to do is we're going to choose the biggest exponent of x, which is the cube. So when we go to write this in standard form, we would have negative 4x cubed. Then x squared would be after that, so positive 2x squared y. Then x to the first, that's a positive 9, so plus 9xy. And then plus 6y. All right, for number 7, we've got 12x plus 1. That x has a degree of 1. The 1 has a degree of 0. That's in standard form, so we don't have to worry about that. And our biggest degree is 1. The degree here is 1. And when a degree is 1, it makes it a linear function. All right? Go ahead and do this one for me real quick. It'll only take you a second. All right, so looking at this right here, this trinomial, we've got a degree of 2 for that term, a degree of 1 for that term, and this is our constant, so a degree of 0. It's 2, 1, 0, so it's in descending order, so it's already in standard form. The biggest degree is 2, so when you have a degree of 2, it is a quadratic function. And that, ladies and gentlemen, are how you classify a polynomial by either the number of terms or your degree. All right, so flipping over to the back side. All right, so we got some examples. So let's go through these. All right, it says identify by degree and terms. All right, so here we have a degree of 2. Here we have a degree of 3. The 3 is the biggest one, so that makes it a cubic. And we have 2 terms, so that's going to be a cubic binomial. For part B, we've got 1, 2, 3 terms, so I know it's going to be a trinomial. This term has a degree of 2, this term has a degree of 4, and this term has a degree of 0. The biggest degree is 4, that makes it a quartic. So here we have a quartic trinomial.